number 4. The rendering equation calculates the outgoing radiance LO in the direction V for a surface patch at location X with normal n. The outgoing radiance is the sum of two terms. The first term is the emitted radiance LE in the direction V. This term is only larger than 0 if the surface is a light source that produces some radiant flux itself. The second term is the integral over the complete solid angle of the hemisphere above the surface. We integrate over the contributions from all incoming radiances Li from the hemisphere above the surface patch. Each incoming radiance Li from direction L generates an irradiance contribution dE. Each infinitesimal irradiance contribution dE is multiplied by the BRDF, which is short for bidirectional reflection distribution function. The BRDF defines how much radiance is emitted by the surface patch in direction V if it receives an irradiance contribution from direction L. This way, the BRDF describes the material properties of the surface patch. This is where we need to insert the microfacet BRDF that we discussed today. Here you see the equation for the complete BRDF. A quick introduction of the used notation before we talk about it. V is the outgoing view direction. L is the light direction. It points from the surface location towards the light. Consequently, minus L is the incoming vector from the light to the surface. N is the surface normal. H is the halfway vector. It is a unit vector at the half angle between the view and the light direction. The BRDF is a function of the view and the light direction. It has a diffuse part and a specular part. The constant diffuse part, ρd divided by pi, is known from the normalized Phong BRDF that we have introduced in episode number 4. For the specular part, we use the Cook-Torrance microfacet model. The Cook-Torrance microfacet model has three terms: Fresnel reflectance, the normal distribution function, and the geometry term. We will introduce these terms one by one in the following slides. Let's start with Fresnel.